Now that we've looked at the slope of a line and the equations of a line, let's look at how to graph a line. There are three big methods I'm going to look at today. The first method I'm going to look at is known as the point plotting method. Let's consider the equation y equal to 2x minus 1. The point plotting method builds a table where we pick some values of x and find corresponding values of y. So let's try -2, -1, 0, 1, and 2. My equation is 2x minus 1, so 2 times -2 is -4, minus 1 is -5. 2 times -1 is -2, minus 1 is -3. 2 times 0 is 0, minus 1 is -1. 2 times 1 is 2, minus 1 is 1. And finally, 2 times 2 is 4, minus 1 would be 3. And then I can plot these points. Over here, go over -2 and down 5 to get to this point here. Next, we go over -1 and down 3, over 0 and down 1, over 1 and up 1, and then over 2 and up 3. And then we can draw the line that passes through these points. This is not a great attempt at that, but we get the idea. We plug some points in for x, figure out the resulting y's, and connect the dots. Next is the slope-intercept method for graphing lines. Let's once again consider the line 2x minus 1. We know the slope is 2 and the y-intercept is -1. This means it crosses the y-axis at -1. The slope being 2, remember this is rise over run. So for every 2 rise, I should have 1 run. In other words, starting at this point, for every 2 I go up, I should go 1 over. And I can continue that at this point, go up 2 and over 1. And I can continue that until I get the equation of, or the points on my line. And I can once again connect the dots. My next method is using intercepts. In this case, we know the y-intercept is -1 because of the appropriate form of this. The x-intercept occurs when y is equal to 0. So in other words, y equal to 2x minus 1 becomes 0 equal to 2x minus 1. And I'm going to skip the steps, but if you solve this, you get x equal to 1/2. So while I cross the y-axis at -1, I cross the x-axis at 1/2. And then I can connect these 2 points and draw the line between them. So these are my 3 methods. Let's look at another example. Let's look at the equation y equal to 2/3 x plus 2, and I'm going to plot this all 3 of our ways. The first was point plotting. Pick some numbers for x and solve for y. Because of the fraction, I'm going to pick -3, 0, and 3. 2/3 times -3 would be -2, plus 2 is 0. 2/3 times 0 is 0, plus 2 is 2. And 2/3 times 3 is 2, plus 2 is 4. So then I can plot these points. Over -3 and down 0. Over 0 and up 2. And over 3 and up 4. And then I can connect the line, connect the dots with the line between them to get the graph of the line. My next method uses the slope of 2/3 and the intercept of 2. We plot the point 0, 2, the y-intercept, and this is rise over run. So for every 2 I go up, I should go over 3. And I can continue this process going up to and over 3. And I can connect these dots to get the graph of the line, which we can see is the same as it was before. My final method looks at the intercepts. We know the y-intercept is 2, so this is where it crosses the y-axis. The x-intercept happens when y is equal to 0, so 0 equal to 2/3 x plus 2. I can subtract 2 from both sides, multiply by 3, and divide by 2 to get -3 is equal to x. So that tells me my x-intercept is -3. And then I can once again draw a line to connect the dots. And I have the same line I had the other 2 methods. The next thing I want to talk about are horizontal and vertical lines. From the previous video, I got that horizontal lines are of the form y equal to a number, like y equal to 2. By saying y equal to 2, what we mean is go up 2 on the y-axis, and then it doesn't matter what x is because I'm not giving x any restrictions. I'm just saying that I need to be up 2 on the y-axis and nothing else matters. So it would look like this horizontal line. On the other hand, when I say vertical line, something of the form like x equal to -3, this means I'm going -3 in the x direction with no restrictions on the y direction. So it looks like this vertical line. Y can vary, but x needs to be equal to -3 no matter what.